Hello everyone. In this video, we are going to discuss the first type of numerical, which is based on the conversion of the flood hydrograph into the unit hydrograph. So let's start. The first problem, it says that the peak of a flood hydrograph due to 3 hours storm in a catchment area is 270 cubic meter per second. That is the peak discharge given for a particular storm duration. The total depth because of the storm that has occurred, it is equal to 5.9 centimeter. Assuming an average infiltration loss of 0.3 centimeter per hour and a constant base flow of 20 cubic meter per second, we have to estimate the two values, that what will be the peak of the unit hydrograph for the catchment area and for the given duration of the storm. That is the first thing to calculate. Then if the area of the catchment that is given equal to 567 square kilometers, determine the base width, that means the base time of the 3 hours unit hydrograph by assuming it to be a triangular hydrograph in this shape. So these are the things which we have to calculate. So starting with the first one. So for the 3 hours storm, the storm value that is given to us for the 3 hours. So for the 3 hour storm, the rainfall that has occurred, and rather it would be right to write the total rainfall that is equal to 5.9 centimeter. The infiltration loss on an average basis, that is equal to 0.3 centimeter per hour. That means in 1 hour the infiltration loss is of 0.3 centimeter. Therefore, total infiltration loss that has occurred for the given duration of the storm, that is 0.3 into 3 centimeters, and that would be equal to 0.9 centimeters. Therefore, the excess, or what we call as the effective rainfall, that means the portion of the rainfall that is contributing towards the direct runoff or the surface runoff, that is equal to the total rainfall minus the total infiltration loss. So from here, this effective rainfall depth that we are getting, that is equal to 5 centimeter. Now from here we have got the effective rainfall depth for the 3 hour storm. That means in this 3 hour, if this was the catchment area, and for this the area is already given, that is 567 square kilometer. Now within this area, if we look at the level of the water which has accumulated here, that is equal to 5 centimeter in this 3 hour storm. Now we have to calculate in the first step what will be the unit hydrograph. So we do not know anything as such. So if we look at the flood hydrograph first, so we know that the hydrograph is a plot between the discharge and the time, with the discharge being shown on the y-axis and the duration shown on the x-axis. Now for this flood hydrograph, that will be starting with certain value which will be equal to the base flow, and then again going back to that value. So this peak discharge that has been already given to us, that it is equal to 270 cubic meter per second. That is the value of the peak discharge. Now the constant base flow that has already been given, and that value is equal to 20 cubic meter per second. So that means this ordinate is equal to 20 cubic meter per second. So if we deduct from the flood hydrograph this 20 cubic meter per second, then the graph that we will be getting, that will start from 0 and that will be something like this and ending again at 0. So this graph that we get, that is corresponding to the direct runoff only, because from here we have subtracted the base flow, and it is also known as the DRH. Now this direct runoff hydrograph, it will be having its peak with the deduction of this base flow, which is equal to 20. Therefore the peak of the direct runoff hydrograph, that is equal to 270 minus 20, and that will be equal to 250 cubic meter per second. Now this direct runoff hydrograph, that has been obtained for the surface runoff of the depth is equal to 5 centimeter. Since the effective rainfall depth, that is ERD, that we have calculated in the previous slide, that was is equal to 5 centimeter. Therefore for 1 centimeter we will be getting the unit hydrograph, and the unit hydrograph's peak will be equal to the DRH peak divided by the effective rainfall depth. So the DRH peak, which is for 5 centimeter, that is 250. So for 1 centimeter it has to be divided by 5. So from here we will get the answer as 50 cubic meter per second. That is the calculation of the first step. Now this is the calculation of the peak of the 3-hour unit hydrograph, and that is equal to 50 cubic meter per second. That is the first step that we have calculated. Now in the next step, it has been given to us that the unit hydrograph for the 3 hours that we are getting, we have to assume it to be a triangular hydrograph, plotting that. So this will be the discharge and this will be the duration. So this is duration T and this is discharge on the y-axis. First value will be 0, then certain maximum value, and then we will be dropping it down. So this base width of the hydrograph, that is known as the TB, which we know as the base time or the base width. This peak discharge that we are getting for the unit hydrograph, that is equal to 50 cubic meter per second, that we have calculated in the first step. Now if you look at the two parameters on the y-axis and the x-axis, we are having the discharge on the one side and duration on the other side. Therefore if we look at the area which is possessed by this unit hydrograph, this area of unit hydrograph or the direct runoff hydrograph, that will be equal to the half into the base into the perpendicular distance. From here this half into base is the TB value into the perpendicular value is the peak discharge. Now this area of unit hydrograph or the DRH, that is equal to the runoff volume. That means the total volume of the water which is flowing in that catchment area, because this cubic meter per second into the second value, that will give us the value of the volume, and that volume is corresponding to the water in the entire catchment area, which we call as the runoff volume. So this half into base into perpendicular distance, that will be equal to the area of the catchment into the effective rainfall depth. So this is the formulation that is used frequently. Now here on this effective rainfall depth, that will be equal to 1 centimeter if we are talking about the unit hydrograph. Now coming back to the problem that we are having. So the peak discharge we already know, that is 50 cubic meter per second. Therefore, this will be half into the base time that we have to calculate into the discharge is 50 cubic meter per second. That is for the unit hydrograph. First of all, let me write the units along with it. So half into TB, let's say we are calculating this TB in seconds, into the 50 cubic meter per second, the area that has been given to us as 567 square kilometer. So the area that has been given, that is 567 square kilometer. From here we will convert into meter. That will be is equal to 567 into 10 raised to the power 6 square meter. So placing that value here in square meter into the unit hydrograph, we will be having the effective rainfall depth as 1 centimeter. So it has to be converted into meter so that we get all the values in that sense only. So to convert this centimeter into meter, we have to divide it by 100. So from here we will calculate the value of TB, that will be in seconds, and that will be equal to 226,800 seconds. Now to convert it into the sensible units, that will be the hours. We have to divide it by the 3600. So the answer that we will be getting for the base width, that is equal to 63 hours. So the base period of this triangular hydrograph, that will be equal to 63 hours. And that completes the first problem. Moving on to the next one. The problem says following are the ordinates for a flood hydrograph which is resulting from an isolated storm. That means there was no other storm than this of the 6 hours duration. So the rainfall occurred for the 6-hour duration, corresponding to which we have collected the data for 0 hours, then 12 hours, and after that at 12 hours apart. So 5, 15, 40, 80, 60, 50, 25, 15 and 5. These are the ordinates of the hydrograph. And when we are having the hydrograph ordinates directly for the entire storm, those ordinates are corresponding to the flood hydrograph. What we have to calculate is to determine the ordinate of 1 centimeter and 6 hours unit hydrograph if the catchment area is 650 square kilometer. That we have to calculate. Now if you look at the data closely and plot the curve according to that, so the hydrograph will be the discharge on y-axis and the duration on the x-axis. So the first value is 5 corresponding to 0 time, then corresponding to 12 it is 15, then corresponding to 24 it is 40, then 80, then 60, 50, 15 and 5. So that means the curve that we will be getting, that will be somewhat like this. So that means it has started at the 0 hour, corresponding to which the minimum value was 5 cubic meter per second. So from the curve it is clear that a straight line is assumed at 5 cubic meter per second, which is corresponding to the base flow. So from the curve it is clear that the base flow for the given flood hydrograph is 5 cubic meter per second. Therefore, to obtain the ordinates of the direct runoff hydrograph, what we will do, we will write down the ordinates of the flood hydrograph, that is FH, and we have to deduct the base flow from the each of the ordinate of the flood hydrograph. So first column would be corresponding to the time, and that in hours. So we have started at 0, then 12, 24, 36, then 48, 60, then 72, then 84. Then the ordinates of the flood hydrograph, and that is equal to 5, then 15, then 40, then 80, then 60, then 50, then 25, then 15, and lastly for 96 it is 5. Now from the given data we have interpreted one value, that is for the base flow, that is in cubic meter per second, and that value is constant at 5 cubic meter per second for the entire storm. So the ordinate of the DRH, that is calculated by subtracting these two values. So 5 minus 5, that is 0, then 10, then 40 minus 5, that is 35, then 75, 55, 45, 20, 10, and then again 0. These are the ordinates of the direct runoff hydrograph. Now to convert it back into the unit hydrograph, we have to divide it by the effective rainfall. Now we have to determine the ordinate of the 1 centimeter hydrograph. That means we are talking about the unit hydrograph, and the duration will be the same, that is for the 6 hours. That means we have to directly convert this into the unit hydrograph. So we have obtained the direct runoff hydrograph. So we know that the area of direct runoff hydrograph, that is equal to the runoff volume. This we have learned in the previous problem. So the area of direct runoff hydrograph, that will be obtained for all of these values. So if we plot this curve, that is corresponding to 0, then corresponding to 12, 24, 36, 48, 60, 72, then 84, then at 96. So starting with the 0, then 10, then it is 35, then it is 75, then 55, then 45, 20, 10, and then 0. So connecting these points by the straight line so that we get the regular geometry, this will be the curve that we will be getting. Now each segment has to be divided into the triangular portion and the trapezoidal portion so that we can carry out the easier calculations. So this runoff volume, that is equal to the area into the effective rainfall depth, and here the area is of the catchment, and that is equal to the area of the direct runoff hydrograph. So from here the area will be, for the first one, this ordinate was 10, so this value will be half into 10 into 12 hours, so converting it into the seconds. This will be the first ordinate or the area of this first portion. Then similarly for the trapezoidal portions, if we calculate this entire area, then we will get the answer as 108 and 5 times 0, that is 1 crore 8 lakh cubic meter of the runoff volume. Now the catchment area that we are having is of 650 square kilometer. So writing catchment area as 650 into 10 raised to the power 6 square meter into the effective rainfall depth, that is equal to 108,000 then 000 cubic meter. From here the effective rainfall depth that we will get, that is equal to 0.0166 meter. Converting it into centimeter, it will be 1.66 centimeter. Now this is the effective rainfall depth. Therefore, to get the ordinates of the unit hydrograph, what we have to do, now to get ordinates of the unit hydrograph, we have to divide the ordinates of the direct runoff hydrograph by the effective rainfall depth, and then we will get all the ordinates corresponding to 1 centimeter depth. So 0 by 1.6 centimeter, that is 0. Then 10 by 1.66, that value is 6.024. That will be in cubic meter per second. Then dividing 35 by 1.66, this will be 21.084. Then 75 divided by 1.66, that is 45.18. Then 55 divided by 1.66, that is 33.13. Then 45 divided by 1.66, that is 27.11. Then 20 by 1.66, that is 12.05. Then 10 by 1.66, again 6.024, and then 0. So these are the ordinates of the unit hydrograph for the given duration of the storm, that is for the 6 hours, corresponding to the given catchment area which was asked in the problem, to determine the ordinates of the 1 centimeter and 6 hours unit hydrograph. Now in the next video we will solve the another set of problems which will be based upon the phi index and the W index. Thank you.